Welcome to the Henkel booth here at SMT Hybrid Packaging. Delighted to be joined by Richard Boyle, who is product manager?
The Global Technical Champion, I think, is my title at the moment and I concentrate mainly on the solder materials, but looking over the whole of the product range within Henkel now, and what benefits we can have from all of the products that we currently supply. Right.
Well, I mean, Henkel obviously manufactures a very, very wide range of different products, from encapsulants and materials up to solders, etc. Let's talk a little bit about the compatibility of these materials, because one of the issues in electronics manufacturing generally is CTE mismatches.
Absolutely.
And the minute you apply heat to that process, everything goes pear-shaped.
And that's not only down to the physical characteristics, the CTE mismatch as well. You have the opportunity perhaps for some of chemical interactions that you weren't expecting to suddenly occur.
Right.
What you'll find is a customer will approve a single product remotely from anything else. So they will approve an underfill, or they will approve a conformal coating, or they will approve an adhesive, but they don't test them all together. And that can sometimes throw up some interesting results, because you don't know what's going to happen. If you undercure one, if you don't do exactly the right thing with something else, you may have chemicals there you weren't expecting to see. Within the Henkel group, we're quite fortunate, I would say, because we have that ability with the whole range of products we have to look at what interactions there could be. As a company, we're looking to develop materials that are, I would say, looking to be best in class in everything, but specifically from an environmental and from a sustainability point of view. So we want chemicals, we want products that are as safe as possible, as robust as possible be on the board. But again, as an individual product, you can test that and you can say, yes, this is fantastic. Yeah. But then when you combine, say, a conformal coating with a solder paste, you don't know necessarily what that reaction is going to be. So part of the development process we have now is to look at that interaction, that compatibility. So working with the solder products, that comes into contact with pretty much everything that's on the PCB. We, as part of the process there, we're looking at testing those materials with the underfill, with the conformal coating, with firmly conductive materials, with gap pads, with anything that you might put on top of the PCB to make the final product, to make sure that they all work together, which is great for us, and it's something that works well, I think, as the company, because we have all of those products. But my concern generally is with the wider industry, where someone is perhaps using a material they've used for 15, 20 years, very happy with it, perfectly safe, no issues at all. But what they tested it with, what they approved it with, is nothing like what they're using now. And then they're adding more materials on top. And I think as an industry, we need to take a step back from who does what, who's to blame for what we're doing here, to look at coming up with a solution that enables us all to show that there's compatibility with individual groups.
I think that's essential. I mean, I think it's going to become an essential part of the mix anyway going forward, because once we arrive at the point where we can make all these machines talk to each other seamlessly, the next step is going to be to digitize the materials characteristics and data.
Absolutely, I would agree 100%. And what the end customer wants isn't for us to say it's perfectly safe, don't worry, which is, it's a step forward. But what they actually need is maybe an independent test house that has that depository, has that library of those connections to say, we know if you're using this amount of power, this temperature, something within that range, these products work together. There's no
and even further than that, they've got to look at these, even once they get these material sets identified, how do they travel? What's the storage? What are they like in different environments,
exactly.
etc.?
I mean, you can look at a production line in a beautiful factory in Europe where they're making maybe 100 or 200 products a week. You then take that same material set to a factory that's producing 20,000 products a day, and the combination is completely different, and the handling process and everything else is different. So there's more potential for interaction, for oddities to occur, for things to happen that you never expected to happen.
I think you're right, and the other thing that's going to push this forward is, as we talked earlier, is the the lot sizes are reducing.
Yes.
What's happening is there's more customization coming into the business, so people are not making, as you said, 5,000 of a product, they're making 500.
Yep.
So the decisions time for the material
becomes
sets
a lot
shorter.
shorter. You've got to make that decision instantly.
Right.
And it's moving, as you say, it's moving forward to that, moving on from the Industry 4.0. We're looking at situations now where someone like Amazon might suddenly say, I need 500 tablets next week.
Right.
And the person producing that has to produce those 500 to deliver on the day that you want. Not hold a massive store, not have 50,000 being produced in one go. Right. That amount of flexibility. You're probably looking at smaller factories closer to the end customer, closer to the warehouse, much more flexibility. Yeah. And that flexibility is where potentially you can get a mismatch happening, because you don't want to be cleaning off product A from and then putting product B on. You want to be running continuously with something.
Absolutely.
And that's where the processing becomes a lot more, I would say, more strict but more flexible. So you've got to have better controls of what you're doing, but be as flexible as possible.
No, it's a fascinating subject, Richard. I could talk about it all day, but you know, let's get back to the real world for a moment. It certainly is the future. There's no doubt about it. Looking at applications today, though, we're having massive debates between jet printing and stencil printing. What is your view on this?
I think, to be honest, I think in the short, medium term, there's obviously going to be a need for stencil printing, because that's the way it is. People produce a two-dimensional board. The quickest way of doing that, by far, is by stencil. Even with the fastest machines in the world. We have a test board that we use. We have different equipment. We can print a test board in 12 seconds. Mm-hmm. We can jet the material in 2.5 minutes. There's a difference there. Now, there's also a quality difference. There's benefits for each one. But I think for the future, that's going to become a lot more integrated, because you're going to have on the PCB, you're going to have high power, close to very, very small, very fine pitch devices, and you can't have that printing in one go. Right. Even with step stencils, there's going to be limitations to what you need to do. So I can see the future being having to integrate initially the stencil printing, followed by jetting for adding additional material or for doing those fine pitch products. Mm-hmm. But in the future, wearable tech, 3D materials, you're going to have the ability to do the jetting.
I think so. You know, it's just the need to get the jetting faster and to come up with line speed. But you know, coming back to what we were talking about a few minutes ago, it's also going to fold into this fact of the smaller job lots.
Yes,
you know,
absolutely.
You know, job lot one, whatever they call it.
And the flexibility of a jetting machine is you just barcode the next product you want to do, and it's instantly set up.
Right.
For printing, the limitation is you have to take out the stencil, you have to clean it, you have to put a new stencil in, and that can, in some factories I've been to, take 20 minutes. In other factories, it can take hours.
Right.
And you don't have that time. You don't have that capability. Time is expensive. Jetting machine, you just barcode and it's done.
And I think also it's going to cut down on, jetting machines cut down on the defects that you get, because defects are obviously, the 70% of the process defects come from the printer, but a lot of it's because of the stencil.
Absolutely, and we've always said that maybe 70% of the defects you have at your end of your production line is from the printing process, and a lot of that is down to handling of the stencil, maybe damage to the stencil, even the way the solder paste has been handled, the way the solder paste is put on, squeegees. There's so many factors that come into it, whereas if you're jetting, as long as the material in the jet head is stable, you're going to get a very repeatable result. Maybe not the same speed, maybe not the same number, but for that type of tech, that's exactly what you want.
I totally agree. Fascinating talking to you, Richard.
Thank you very much. Anytime, you know.
Thank you for giving us a glimpse into the future.
Okay, thank you very much.